Hello, this is my math journal video project on functions. So first, we're going to start with definitions. We can define a function as an equation in which every input has one output, or a graph, or a table, but they all come back to each other. And domain we can define as the inputs, or to make it more simple, we can define it as all of the x values from the most left to the most right point. And the range is all of the outputs, otherwise known as all of the y values from lowest to highest. So we could get started now with the equations. So first, we see that this is a function, right? For every input, there's only one output. So if we input 1, our output's 1. If we input 2, our output's 2. If we input 3, our output's 3, 4, 4. And this is a counterexample. So let's just say this yellow line is 5, right? And this is 5, and this is negative 5. We input 5, and we get both 5 as an output and negative 5 as an output. Meaning that this has two different outputs. So now, to describe and find the domain and range, first to find the domain, if we were to just go, act like these arrows are just dots, we'd find that the domain from left to right, we'd look up to the x value, see that this is negative 4 to all the way to 4. And same with the range, we would look at the lowest and highest point, so it'd be negative 4 to 4 as well. So if you only had the output, or if you only had the input on a graph and you needed to find the output, what you would do is you have the input of 3, and you'd go up or down, however many, to where it would intersect, which here is 3, but it varies per graph. So now I move on to tables. This table is a function, and it is a function because for every input, it has an output. It has only one output. So let's say these were candy bars. If I bought one candy bar, it would be $2. 2, 4. If I bought 4, it would be 8. So it's the same pattern of adding 2 each time. Now for a counterexample is right here. If I bought 3 candy bars, it would only cost $1. 3 candy bars, 2, 3 candy bars, 3, 3 candy bars, 4. So it's sort of like, it's not really the same. And basically, going back to this, it wouldn't really line up. And if we go back to the graph, it would be saying like 3, if we put the input as 3, we get 1. We also get 2. We also get 3. We also get 4. So there is not one input for every output. So to find the domain and range, we'll use this first example. First, we can find the domain, but it's just like graphs. We can go left to right. Domain is the input, so the domain is 0 all the way to 6. And the range is just the same. It would be up and down on a graph, but here it's projected left to right. So still the same thing. It would be $0 to $12. So now we have to find one way to find an output given the inputs. The best way to do it, in my opinion, is to find the sort of like the equation to it. So we see 1 and 3, and if we're to subtract them, just in this case, since it's being added by 3 every time, we'd find that this is 6 as the middle one. So this would be easier with more if I were to, per se, have like 4 and 12, then it would make more sense because you could see that every time it was being added by 3. So this missing output would be 6. Now equations, I'll add one more to make it more simple, is just about the same thing. So we can see that it's being added by 3 for every 1, right? So we see that if it's being added by 3 for every 1, we can subtract 3 from the value of 3 to find that. Sorry, let me reset that. We can subtract 3, or no, to go down 1, we would simply either see how it's being added by 3 each time, and then notice that this is the second one, considering it's the second time being added by 3. Now for equations, um, equations, to make sure they have one consistent output, you would solve them. So for here, we'll do 2 times 1 plus 1 equals 3. 2 times 2 plus 1 equals 5. 2 times 3 plus 1 equals 7. Now we can just 4 and 5. And now we find out that, that this equals 9 and this equals 11. So for every input, the input of 1, we get 3. Input of 2, we get 5. Input of 3, we get 7. So there's one input for every output. Now a counterexample is y squared equals x. Let's say x was equal to 4, just for here. So that'd be 4 equals 4 squared. So that would equal 16. So it'd be 4 equals 16. Oh. But how this isn't a function is that if we were to say x is negative 4, so negative 4 equals negative 4 squared. When we square negative 4, we'd also get 16. So that means 4 and negative 4 are both 16, which means there is not one input for every output. Now, to find domain and range. So for this, we can find the domain as the x's. So here, let's say it was solved for a through e, we would find that the domain is 1 through 5. So put it here, d equals 1 to 5. And then to find the range, it would be the output. So we see that the range is 3 to 11. So to find an output given an input would just be to solve. So let's say we wanted to find the output, which is y. All we would have to do is solve, and we'd find that y equals 5. Now, to find an input given our output, let's say we know 5 equals 2x plus 1. We'd use inverse operation. So first we'd subtract 1 from both sides. minus 1 minus 1, and that would become 4 equals 2x. And then divide by 2 to get to x by itself. And we'd find that this becomes 2, and this just becomes x. So x equals 2. Now, a real life non-number related function, one I like to use, is buttons. So we have Coke, Fanta, Sprite, and Coke Zero. So if we click the Coke button, we get Coke. If we click the Fanta button, we should get Fanta. Sprite, Sprite, and Coke Zero is Coke Zero. So this is a function because when we click something, we get the same thing every time. Another thing that could happen is if we click Coke and we get Fanta, it would still be a function as long as we get Fanta every time we click Coke. So this could still be a function. But one thing that isn't a function is if we go and we have them all normal. Coke, Fanta, Sprite. But then on this last one, what we get is Sprite. So we see that we click Coke once, we get Coke, but the other time we click Coke, we get Sprite. So it would not be an input, or it would not be a function, because for the input of Coke, there's two different outputs. And that's all. Thank you and have a good one.